Hey everyone, my name is Prathamesh Kurgavkar. Today I am doing this YouTube link for my course E432 Advanced Computer Vision. This YouTube video gives you information about history of object detection, a survey. I am a student from Northwest University, Masters of Science in Mechanical Engineering, and Professor Ying Hua from Northwest University is guiding me throughout this project. So we can start now. So moving into the project, moving into the PPT. First, we need to understand the timeline of the object detection. So basically, the object detection is divided into two parts. One is a traditional method, and another is a deep learning based method. So as you can understand that the period before 2012 generally considered as a traditional detection method zone, and the before after that considered as a deep learning based detection method. So in the traditional method, there are some methods considered as a VG detection method. There is hog detection methods and DPM. These are the very famous methods and the milestones in the traditional detection method. After 2012, there are the deep learning detection methods are divided into two parts. One is the one-stage detector and another is two-stage detectors. So there are some famous method in one-stage detectors like YOLO, SSD, RetinaNet. There are some famous methods in two-stage detectors such as the RCNN, faster RCNN, SPPNet. So we can look into that. So next slide. So before moving into the main things, we need to understand the some basics in the basics, like the difference between the traditional object detection and the deep learning based object detection. So in the traditional object detection, we have a input. We do a feature engineering, that is the manual extraction and the selection. So in this manual extraction and selections, we basically build a data set that we wanted to extract the features from. Then we have a classifier with a shallow structure, and after doing this all the things, we can get an output. So after that, we need to understand the uh, deep learning detection method. So in deep learning detection method, as you know that there is input, there is a black box, that is our neural network. So basically neural network do the feature engineering plus classifying of the object, and then we can get an output. So uh, as you know that deep learning based detection methods has two parts. One is a two-stage detectors and one is one-stage detector. In two-stage detector, we have input image, we have feature extractor, then there is RPN, a regional proposal network, or basically you have a proposal generator that generates proposal, like basically that classifies the object, builds the box regressions, and then feed that information to detection generator. So that's why this process is more accurate, but it takes more time because it's computationally very time consuming, also complex. The next method is one stage detector. So one stage detector basically have less accuracy than two stage detectors. They have an input image, they have a feature extractor, and then they directly do the detection generator, that is the classification or regression of the image or the output. So but this method has a direct connection. Because of that, these methods are way much faster than two stage detectors, but they are less accurate. So uh, now we are moving to classification of the object detection. As you know that as I mentioned earlier, the object detection divided into two parts. One is the deep learning based methods and another traditional detection methods. So in our class, we the professor covered some topics, and professor covered some topics. Those are like some these topics. So I wanted to don't want to waste a lot of time on this, but I wanted to give us some sort of a methods that professor introduced in the topic, so I can explain this PPT. And there are some topics that I wanted to emphasize more on, which are not teach in the class. So the first method is the traditional detection method. That is a very famous method, is Viola-Jones detection. This method is introduced by Viola and Jones in 2001. This method has main three features. This method use a sliding window to go through all the locations. Also, this method has hair-like features. These hair-like features are basically a black and white images which try to detect your features in your face. This method is developed to detect the faces in an image. So it has a Harlech features. Also, it has a AdaBoost feature selection, which basically improves the performance of the detection of the algorithm. uh, this the after this all the things, this method also has some limitations. Like this method is less accurate than the other method that develop after that. Also, with a large amount of data set, this method doesn't perform that well. Also, the real-time detection for this method is not that great as compared to the other methods. So we are moving towards the next method now. So the next method in traditional detection method is a cascade SVM approach for head-shoulder detection using histogram of oriented gradients. So HOG is a base method in this. So the histogram of oriented gradients is a method where we have a detection window that basically it divides the image into different boxes, and just if you extract that features from that image to generate a histogram. So these are the basic method. But this cascade SVM approach is this method has a different approach. Basically, in HOG we have a linear SVM and a detection method. But in the cascade SVM we have a cascade SVM that eliminates the linear SVM. Because of that, this reduces the false positive in the image, and also because of that, this method is more accurate than the basic hog method. But after doing this also, this method has some limitation that covered by the next method, that is the deformable part models. So deformable part models is the accurate method, and the method is reliable method than the Hogg and Viola Jones method. This method follows one principle, that is a divide and conquer. So as you can see from the image, that this is the one image that we need to extract the features from the images. But this method specifically extract the different features from the image by different parts. You can see that this method can detect seat, pedals, wheels. Because of that, the accuracy of the object detection improves. This method has three parts for the object detection. One is the part detection, part composition, and scoring and non-maximum suppression. After doing all these things, this method also has some limitations, like limited flexibility for detecting the object, because the traditional detection method has a feature engineering, that is manual extraction. Because of that, these methods are slow, and you can say that these methods are not that accurate, and because of the feature engineering. Also, this method is computationally intensive. So we are moving into the deep learning based method era now. So these all the methods in deep learning based era are classified under one stage detectors and two stage detectors, as I mentioned earlier. So we can now move on to the first method, that is a special pyramid pooling in deep convolution networks for visual recognition. So this method is introduced after the RCNN method. So basically the methods before this is like RCNN has a fixed input size. So because of that we need to crop the image, and we need to warp the image, as you can see from the images. So due to this reason, the image has a due to this reason we lost a lot of important features in the images, a lot of important information from the images. To eliminate this, the researcher developed this method, which can take the input from any aspect ratio on various size of scales. So you can see from this structure that basic RCNN has image, then it can crop the image, and then it forwarded to convolution neural network convolution layers. But in the SPP net we have image, we directly feed that image to convolution layers, because this method can take image in various aspects. And after that we can feed this image to the SPP, that is special pyramid pooling, which has basically has a pyramid like structure that can extract the features of the from the image, and then we can forward this information to the fully connected layers, and then we can get the output. So because of this reason, this SPP net eliminate the RPN, that is regional proposal network, and because of that, it also reduces the number of forward passes in the process. So because of the efficiency of this method increases. So next is the, as I mentioned about the RCNN. RCNN is a regional based convolution neural network. This method is the first method that is developed in deep learning based methods. So this method has divided into three parts. One is the regional proposal algorithm that is introduced first time in this method. Then the deep convolution neural network. Then the linear SVM. So as you can see from the diagram is that regional proposal network uh, captures the different regions from the images, and then for the extraction of the features we forward these regions to the CNN can extract the features, and then a linear SVM do the other classification thing from from the images. This method has a different features like box regression, multi-stage detection. Also, there are some advantages of this method. uh, this method can perform detection. Also, this method can perform segmentation. That is a good thing for this method. Also, the flexibility in designing the network for this method is this method is more flexible than the other methods, the methods that before this, like traditional detection methods. So we are moving forward to the next method. So the next method is also comes under the deep learning based detection method, that is a FPN, that is a feature pyramid network for object detection. So as you can see from the images that this method is capable of detecting images with the different sizes and scales. You can see from the architecture of this method, it has a pyramid like structure, that is a top down architecture or bottom up architecture. Also, this method has some lateral connection between the layers. Because of these two things, it can detect the small objects from the images, and that is the major advantage of this algorithm, that is FPN. Also, this FPN reduces the also this FPN reduces the eliminate the regional proposal network from the process. That because of this, the efficiency of the algorithm increases. So this method is very important, and you can see from the further slides that this method is used in lot of other methods in the one stage detectors also. So now we are moving forward to one stage detectors in deep learning based detection method. First is the YOLO. YOLO is you only look once. That is the full form of the YOLO. And YOLO is the method that is very good in detecting the real time detection, as you want to detect the object in videos. Also, the major advantage for the YOLO is that high recall. So basically, uh, YOLO can detect the high percentage of object in an image. This is the main advantage of YOLO. Also, as you know that YOLO is a one stage detector, that's why YOLO is really fast, and it has a less accuracy than the other methods. But the predecessors of the but the methods that come after the YOLO's advanced versions like YOLO v2, YOLO v3, and YOLO v4 can increase the accuracy of the method. As you can see from the table that for on the MS COCO datasets and Pascal VOC datasets, the YOLO v2, v3, and v4 shows a good amount of improvement in the accuracy. So we can move forward to the next method now. So basically, the next method is focal loss dense object detection. That is the RetinaNet. As I mentioned earlier, that FPN is using the different type of one-stage detector. So RetinaNet is the one method that uses the FPN in this network. So you can see from the top-down architecture and the bottom-up architecture and the lateral connection in this method from this method's architecture. So basically, this method solves the accuracy problem for the one-stage detectors. How? Because this method introduces a focal loss function that can identify the class imbalance in the method, and because of that it increases the accuracy and reduces the false positives in the in detection. As I mentioned earlier, this method also uses FPN. Because of that, it can do this kind of things. So so the next two methods are kind of similar to each other, that also comes under the one stage detectors. I mentioned those two processes in one slide. So one is the corner net and another is center net. So corner net, you can see from the framework that corner net has a hourglass like network. Also, the CornerNet can CornerNet can produce the two heat maps at the corner of the images. So because of this, it reduces the convergence in the image. Also, it has a some kind of a key point detection that can increase the speed of the detection, also increase the accuracy of the detection. Also, you can see the framework for the CenterNet at the bottom. CenterNet has the same kind of structure, but but the major difference is that it doesn't detect the point at corners. It find out the point at center and detect the point from that point. So there are some advantages for the CenterNet, that it eliminates the post processing in the method. Because of that, it reduces the time of the detection. uh, you can see there are some advantages of CornerNet. They have like key point detection, as I mentioned earlier. Also, this method has end-to-end training, and also this method use low memory usage. Oh, so that's why the computational time reduces for the process, and we can use a lower end device to use this algorithm in our computers or PCs. But as the CenterNet develops after the CornerNet, some CenterNet has some advantages over a CornerNet. Like CenterNet has a higher accuracy. Also, CenterNet has a high quality of heat maps and speed. Also, it increases the speed. Also, the main advantage of CenterNet has it has a multi-scale detection that is very important in object detection. So moving on to the last slide of the PPT, that I did some comparison between the deep learning based detection methods. There are three methods, like a special pyramid pooling, feature pyramid networks, and Raydian net. So I just compare them on the four parameters. So on the multi-scale feature representation, the SPPNet and FPN have both has a pyramid-like structure. Also, RetinaNet also has a pyramid-like structure. So both methods are similar in this manner. But in the computational complexity, basically the RetinaNet has a simple architecture, and which is much faster and efficient. But the SPP, the special pyramid pooling, and FPN both as computationally very expensive operations. On the accuracy on small object detection, the RetinaNet has a focal loss function, which is a novel architecture. So basically, it improves the accuracy in detection of the small objects. Also, the other two methods like SPPNet and FPN also has effective in detecting small objects due to capturing at multiple scales. So finally, the training complexity. In the training complexity, you can see that SPP, the special pyramid pooling, has fine-tuned using specific data sets. Because of that, it is less flexible and it is harder to train. So this method is harder to train. But the other two methods that can be trained using a standard gradient descent. So they are like easier to train and that can be trained easily. So my PPT end at this point. So thank you very much to all the people who supported me doing this presentation, and I sincerely acknowledge Northwestern University to give me opportunity to do this video. Also, I like to thank Professor Ying Wu of Electrical Engineering Department from Northwestern University to guiding me throughout this project. Thank you so much.